All right, welcome to the Explainer. Today, we're heading to West Africa, digging into a really fascinating report from the US Geological Survey. It's all about peeling back the sand and dust to see what's hiding underneath. So let's get our investigation started. So think of this as a kind of geological detective story. We're on a mission, right? We're trying to figure out the secrets that are hidden just below the surface of Mauritania's massive deserts. And the biggest question, the one we're really chasing today, is what kind of treasure is actually buried down there? And the target of our investigation is one specific element, uranium. Now, we're basing this all on a super detailed study that was done for the Mauritanian government. We're going to follow the clues laid out in that report to get a real handle on just how big this country's uranium potential could be. Okay, first big clue. It's just a number. 80. That's how many known uranium presences have been found scattered across the country. 80. I mean, that's a huge number, right? It tells you right away that geologically, something interesting is happening here. But, and this is a big but, that's not the whole picture.
And here's why. You've got to understand the difference between a presence and a deposit. It's absolutely key. Finding a presence, well, it's like finding a single footprint in the sand. You know something was there, but that's about it. A deposit, that's different. That's when you have the whole trail, enough evidence to actually estimate how much might be there. So out of those 80 footprints, only 17 are solid enough to be called real confirmed deposits.
You know, this search for uranium in Mauritania isn't some new thing. It's been going on for a while, in roughly 3 stages. It all started way back with French agencies like Kojima, who did the early groundwork. Then, fast forward to the early 2000s, and you get the real game changer. This project called PRISM, which methodically mapped the whole country. And that opened the floodgates for the modern era of private companies jumping in and exploring. So let's talk about those lead detectives, the PRISM project. I mean, this was a massive, massive effort. And honestly, it's the absolute heart of our story today. This is the moment we go from a few scattered clues to something that looks a lot more like a treasure map. So who was running this thing? It was a team effort between the US Geological Survey, the USGS, and the government of Mauritania. Their goal was, simple on paper, but incredibly ambitious in reality, to create the very first systematic mineral resource map of the entire country. They were looking for everything, not just uranium, but boy, did uranium turn out to be one of the star players. And like any good investigation, they had a clear plan. It was basically a 3-step process. Step 1, they dug up all the old data, all the existing maps and reports. Step 2, they went out and got a ton of new data. We're talking planes in the air with special sensors, thousands of rock samples on the ground. And then step 3, they mashed it all together to figure out, okay, where are the really promising spots? So after all that work, what did they actually find? Well, the data pointed to 2 main types of places where you find uranium in Mauritania. And getting a grip on these 2 types, that's really the key to the whole puzzle. And check this out. What's so wild here is how one type just completely dominates. Look at the breakdown of those 80 presences we talked about. A whopping 70%, are this thing called calcrete. That makes it our #1 target for sure. Then you have another 15% found inside granite, but calcrete is clearly the main event. So you're probably asking, what on earth is calcrete? The easiest way to think about it is like a geological sponge. Imagine you're in a really dry place. You have groundwater that's picked up bits of uranium, and it gets sucked up towards the surface, kind of like water through a straw. When that water evaporates in the heat, guess what it leaves behind? The uranium. It gets concentrated right there in the soil just below the surface. So they're shallow, easy to access deposits. Let's put them side by side. The calcrete deposits, they're shallow. And look at the numbers. They represent a way bigger potential resource, over 138 million tons, with a higher average grade or concentration. Now, the granite ones, they're deeper down in the solid rock. The total potential is smaller, and the grade is a little lower. So you can see why explorers get really excited about the calcrete, right? Bigger, richer, and closer to the surface. All right, this is the big reveal. This is the moment everything we've talked about, the history, the geology, all that data from the PRISM project, it all comes together. The investigation gave us the clues, and now, finally, we get to see the treasure map. And you know what the single most important clue was? It came from the sky. Those planes the PRISM project flew,
They had sensors that could literally detect the faint radioactive signature of uranium from the air. It's incredible. And what they saw were these huge hotspots of radioactivity, especially over this giant geological area up north called the Rgueïbat Shield. That's it. That's our map.
So, using that map, the geologists drew circles around 12 main areas that looked really good for these calcrete deposits. Let's hit a few highlights. You've got zone MU01, which is just massive. It covers most of that uranium-rich Rgueïbat Shield. Then you have zones MU02 and O3, which are super exciting because they have a bunch of known deposits all clustered together, plus really strong signals. And then look at MU11. It's the perfect textbook case, a crazy strong radiometric hotspot sitting right on top of a potential deposit. This is exactly how modern mineral hunting is done. Okay, so we've got the map. We know where X marks the spot, so to speak, but a map isn't the treasure, right? It just tells you where to dig. So what does this all mean in the real world? Who's actually out there digging? And this is where the science hands off to the business side of things. This table just gives you a snapshot of some of the key players. You can see which companies are out there right now trying to turn all this potential into a reality. You've got companies like Aura Energy going after those big, shallow calcrete deposits, while another, Forte Energy, is drilling down into the granite ones. This is the real boots-on-the-ground work that makes it all happen. And really, the report's own conclusion says it best. Mauritania is the site of active uranium exploration, during which new discoveries are being made. That's the key takeaway. This isn't just some old story from a geology textbook. It's happening right now. New things are being found. That PRISM project basically drew the map, and now the race is on. So, we kind of end up back where we started, but now we know a lot more. There's no doubt the sands of Mauritania are hiding a genuine geological treasure. The science has pointed the way, and the explorers are out there now. But that leaves us with the biggest question of all, doesn't it? A geological treasure for what kind of future? That's the real story to watch. Thanks for joining this explainer.